Determine the force in member BC. Where is BC? This is BC. CF. CF. And FG. FG. And indicate if the members are in tension or compression. Each member in the truss is 0.6 meter long. Okay, so we know that distance is 0.6, distance is 0.6, distance is 0.6. So every member is 0.6 meter long. Now, okay. So I need to remember, I need to make a section where I get the unknown members. And so I cut the section where I've got the unknown members. That's the place to cut your section. So if I cut from here, let me get rid of this. So how many members I'm cutting which are unknown? So that this one is the only unknown. This we are not interested in the forces here. So that's not the right way of sectioning it. Okay, let me section here. There's no purpose of sectioning here because we are not doing analysis on those members. So that's not the right place to section it. Okay, let us make a section here. So I've got 1, 2, 3, 4. No, it should be maximum of 3 members. Although I've got 2 members here, which I'm interested in, but I'm not interested in this one and this one. So the obvious cross section means that I should section it from here. So it means I have got 3 members and all those members are of interest to me. So I section it from the place where I got the unknown members and you got 3 members. Is that clear?
So yes, section through the members that we are supposed to find.
Yes, yeah, you cut those members of which you normally, in most of the cases, you cut those members of which you need to find the value. We need to find the value of this one, we need to find the value of this one, and we need to find the value of this one. And the sectioning should include a maximum of 3 members. So obviously, this is the right place to section. Is that clear?
Yes, sir.
Okay, so we section it from there, and then you've got 2 sections. So if I section it from here, I have got 1 section here, and I've got the other section here. I've got section A and section B. I can pick anyone. I can pick this one or this one, because if I do the analysis on this one, I've got my 3 members included. If I do the analysis on this one, I've already got my 3 members included in it. But to reach to those members here, I have to start my analysis from here and then reach here. Can I do it from here? We don't know. Let us have a look at the solution and everything gets clear. So you've got 2 sections, this and that. Okay. And as it says here, from each segment, this is 1 segment and this is this other segment. From each segment, you can solve for maximum 3 reactions. Got 3 equations, so naturally you get 3 reactions you can solve. So, question is, question is which one? Okay, let me look at this segment first. Okay, let me see. I pick segment B for my analysis. Okay, so what I've got this unknown, reaction support force, and this unknown. Look, remember one thing. If I have selected this segment, I will draw the free-body diagram of the segment. That is there. I'm not going inside the system. Okay, I am not going inside the system. Excuse me. Inside the system means I'm not interested in finding the forces in this member, this member, and this member. I'm not interested. I will draw the free body diagram of the section. So the section means if you draw the free body diagram of this one, I will have this force, I will have this force, I will have this force, and I will have two reaction forces there. This is a pin collection, so it's free to rotate but cannot move in XY direction. So if I draw the free body diagram of segment B, I will have 5 unknowns and I have no unknowns. So I will create a lot of equations which will be of no use. Am I right?
Yes, sir.
Okay, so let's now look at segment A. So now I'll look at segment A then. Segment A. If I draw the free body diagram of segment A, I will have this unknown, this unknown, this unknown, actually active force, and this is a roller, so I will have only one active support force. So question is, which segment should I choose? Should I go for A or should I go for B?
A.
You could
A.
go for
A. Obviously, because in A you've got the known forces, in B you don't have anything. So you start your analysis. Sorry.
or what you could do is like you could take moments about A to find the normal force at D and then go with section B.
Yes, yes. So my question, basically what I mean to say that you're going to pick segment A or you're going to pick segment B. Obviously, you are going to pick segment A. Is that clear?
Okay.
Okay.
Yes, sir.
So let me pick segment A. So this is of no use to us. We look at segment A. Okay. Now in segment A, can I solve the problem? Or will I have a lot of equations? If I take moment at point A, I will have this force, I'll have this force, and not this one.
Yep.
So I don't know. Will I be able to solve the problem? I don't know, because I will. If I take the moment, I'll have two. I will have. If I take moment at A, I will have this and this component as unknown. Then I do a sum of all the forces along y-axis. I will have this as unknown. If I do sum of all the force along x-axis, I will have this one component of this one and this one unknown. I guess I will have a lot of equations, but I will not be able to solve the problem. Try, give it a try, and I'm pretty sure you will not be able to solve the problem. So if you got a lot of equations and you're not getting the answer, the obvious thing to do is draw the free body diagram of the whole structure first and try to find your support reaction. Remember? Is that clear? So if I'm not able to find the forces in those members, I get a lot of questions. So obvious thing to do is to draw the free body diagram of the whole system. I've got AY, I've got DX, DY, not interested in DX, DY, more interested in this A. So I will take a moment at point D. I will be able to get AY out. Am I right?
Yes, sir.
Yes, sir.
So if I've got AY out, it means I have this value, and now I can start my analysis and get, this is basically taking moment and you're getting your AY out. Okay, now another important bit is that, which I want you to keep in mind. We opted for this section. We found this value here. Okay. Now look, I've got this. I've got this unknown. I've got this unknown and this unknown. One of the points being made here about the technique of analysis. Come on. This one, moment, take a moment, okay, at the intersection of the line of action of two unknown forces. That's the point where I want to make clear, is that if you look at this one, I've got this as this unknown. That's the point where they intersect. So I take moment at point C. If I take my moment at point C, this and this does not appear in the equation. So what I will have in the equation is this into its vertical perpendicular distance, this into perpendicular distance, this into perpendicular distance, and this into perpendicular distance. So I will be able to get this out. Am I right?
Yes, sir.
So once I've got this, I've got two unknowns. I will do sum of all the forces along x, sum of all the forces along y. I will get those two out. Clear?
Yes, sir.
Yes, sir.
So it's very obvious. It's very obvious. You can easily do this. What they've done, they've taken the moment at this point, mf. When you take moment at this point, this doesn't appear in the equation, this doesn't appear in the equation, only this appears in the equation. So the beauty of taking moment at unknown is very interesting. We do this normally in solving, whenever we solve industrial problems, we rely on moments. We try to find the point, we've got maximum unknowns, and at that point we apply the moment and we are able to find forces in the component. Is that clear to everyone?
Yes, sir.
Yes.
Okay, because students have normally got the habit of going for sum of all the forces along x and sum of all the forces along y, keeping in mind that moment could be a bit difficult thing because you're going to find perpendicular distance. But you can see the beauty of a moment, taking moment at a point where you got maximum unknown. Those unknowns do not appear in your equation. Keep this thing in mind so that whenever you solve industrial problems, it will help you in doing that.